the law of sines and cosines. This video tutorial can be found at mathwarehouse.com/sines and cosines, as you can see right here. And there's some other goodies on that webpage, some great pictures of when you should use the law of sines, cosines, as well as a free worksheet with an answer key. This tutorial is aimed at students who are already familiar with the basic formula for the law of cosines and the law of sines, but need a little extra practice or just want a little more work on trying to decide when you should be employing the one formula or the other to solve the common types of problems kids have to solve involving sides and angles of a triangle. If you want more practice focusing on either one of these formulas, you can visit that webpage and find links that are dedicated to just the law of cosines and a link dedicated to the law of sines. Alright, so let's just take a quick minute or two to revisit the law of cosines and sines, which you should be familiar with before watching this video. The law of cosines deals with 3 sides and 1 angle. And typically you want to use the law of cosines for 2 different types of problems, which we'll look at in a minute. But I just want to point out law of cosines involves, right now, law of cosines involves 3 sides and an angle. The law of sines, you will always end up setting up one equation that involves an angle, its opposite side, some other angle, and that angle's opposite side. This should be B down here. And that's what distinguishes the law of sines from the law of cosines. The law of sines is going to involve 2 sides, 2 angles. The law of cosines, 3 sides, 1 angle. And we're going to look on the next screen a little more specifically about at the types of triangles that will lend themselves to one formula or the other. Okay. You can now see 4 different pictures representing the common problems students have to solve involving sines or cosines. If you are given 2 sides and 1 opposite angle, like this picture, and you're trying to find an angle opposite a side, for instance, and we'll call this triangle 1, let's call this triangle 2, 3, and 4. If you're trying to find x, you know its opposite side, and you also know a pair of opposite measurements. You know an angle and its opposite side. This is a law of sines problem. We could say the sine of x over 16 equals the sine of 115 over 49. We have one equation, one unknown, so this is solvable. So the key to law of sines problems is looking for sides and angles that are opposite. You need to be able to get one pair of opposite measurements, like the 49 and the 115, and then you need to know one of the other pair. In other words, you need to know the 16 if you're trying to find the x. And now triangle 2. 2 angles, 1 opposite side. So in this case, we have an opposite pair of measurements. We have a side of 11. We have an angle of 118. We're trying to find x. This is the same as our triangle number 1. We know one pair of opposite measurements. We're trying to find an x, and we know its opposite measurement. So this is, again, law of sines. You can say x over the sine of 118 equals 11 over the sine of 29. Okay, law of sines. So what distinguishes triangles 1 and 2 is the fact that you know one pair of opposite measurements, whether it's, let me change the color a little, whether it's right here, 49 and 115, 29 and 11, you know one pair, and whatever you're trying to find, whether it's an angle on the left or a side on the right, you know that thing's opposite measurement. You knew the 16 on the left. You knew the angle opposite the x on the right. So you can set up your law of sines proportion, which always comes down to opposite measurements, opposite sides and angles. Okay, so now let's look at triangle 3. Here we know two sides and an angle, which is the same, and you know two sides and an angle. So at face value, it might look very similar to this. There's two sides and an angle, much like problem 1. However, the difference is here, the angle is in between the sides you know, and you do not know any opposites. Remember, law of sines is about opposite sides and angles. Here, we know 16, but we do not know the angle opposite it. We know 52. We do not know the angle opposite it. We're interested in an angle. We know an angle, and we're interested in its opposite side. If you cannot find an opposite side and angle, like if you cannot know that at the problem start, you cannot use the law of sines. So the only question now is, can we use the law of cosines? And the answer is yes. You can set up the law of cosines to find x. You can say x squared equals 52 squared plus 16 squared minus 2 times 52 times 16 times the cosine of 115. Okay, so when you know two sides, one included angle, and you're trying to get the side opposite the angle, it's the law of cosines problem. Now let's look at triangle 4. We know three sides. We don't know any angles. This is obviously not a law of sines problem. Remember, law of sines requires that you are able to know an opposite side and angle. Not possible. We don't know any angles, and we have no way of getting them. So, can we use the law of cosines? If you think about it, the answer is yes. We can say 24 squared equals 32 squared minus 37 squared minus 2 times 30. Sorry, I'm running out of room here. I'm going to put this on the next line here. Minus 2 times 32 times 37 cosine of x. And you can eventually figure out x in this problem by solving by solving and then taking the cosine inverse. Alright, so this is a law of cosines problem. So let's just recap. Law of sines. You need to be able to get an opposite side and angle. And whatever you're looking for, whether it's an angle or a side, you must know that thing's opposite measurement. Law of cosines is great when you know two sides, an included angle, and you're trying to get the side opposite that included angle. Or when you know three sides and you're trying to find an angle. Alright, so for the rest of this tutorial, we're going to look at at triangles that ask you to find a side or an angle. And we're not even going to actually answer the question. We're not going to actually find the value of the side or angle. We're just going to set it up. And we're going to try to practice the process of determining which formula to use. So let's look at the triangle on the right here. Which formula, if any, can we use? And let's set up that formula without actually solving it. Let's see, we know two angles and the included side. We did not look at this situation in the prior 4 triangles. And at first it might look like none of these formulas work. However, if you just remember one formula, the formula that says that the interior angles of a triangle sum to 180 degrees, we can figure out how large this angle here is. You can just say, 180 degrees is the total interior angle measurement, and then just subtract 30 from that, subtract 116, and you'll be left with how many degrees are left in that triangle. which is 34 degrees. So we can figure out that this is a 34-degree angle, and that allows us to use one of the formulas. Here, we now know an angle, its opposite side, and we know the angles opposite the side we're trying to find. Law of sines. Remember, law of sines is about opposites. You need to know one pair of opposite measurements, which we do know. We know that 19, we can talk about 19 over sine of 34 is going to equal x over the sine of 116. Law of sines. Alright, now let's look at this. Which formula, if any, would we use? And let's set it up without actually solving it. We know 3 sides and 1 angle. You might remember there's no decision to be made here. You just have to, well, there's only one thing that you can do here. Law of cosines. 14 squared equals 12 squared plus 20 squared minus 2 times 12 times 20 cosine of x. Alright, 3 sides, trying to find an angle, law of cosines every time. Alright, I think we'll wrap up this tutorial by looking at 2 more complicated problems. And you'll see what I mean by that as we go through it. And we're actually going to solve this one out here. So let's look at problem 12 from that free worksheet I was mentioning on the website, mathwarehouse.com/sines and cosines. This is question 12 from it. We want to find the measure of C, and as you can see, we don't know any opposite side and angle, and we can't find it in any way. There's no way we can use the trick in the other problem involving the fact that all the angles add up to 180. That's not going to help us out. So our only option is to think about whether we can use the law of cosines. And it turns out if we use the law of cosines to find B, remember, law of cosines is ideal for 2 sides and included angle, and when you're trying to find the side opposite that angle. So we can use the law of cosines to get angle B, and then we will know an opposite side and angle, and we can use the 15 to help us use, as a second part, the law of sines to get our final answer. So this is a more complicated one where you actually have to use the law of cosines and sines. And we can say B squared equals 15 squared plus 19 squared minus 2 times 15 times 19 cosine of 120. And when you punch that into your calculator, you get B squared equals 871. B will be the square root of that, which is 29.5. So we now know that B is 29.5. And now we can use the law of sines. We can say that sine of C that we're trying to find over C, 15, equals sine of B, or the sine of 120, over 29.5. And then it's just a question of using our cross multiplying first. 15 times the sine of 120 over 29.5. When you punch that into your calculator, you will get approximately 0.4403. And then if you take the sine inverse of 0.4403, sine inverse of 0.4403, you should really type the entire decimal into your calculator so that you minimize any rounding error. You will get 26 degrees if you round it to the nearest whole degree. Okay, so it's a little more complicated. It was possible to use the law of cosines to get the side we needed, which would allow us to then use the law of sines to get the angle the question asked for. All right. Okay, the last problem we're going to look at is problem 14 from the worksheet, and it's actually a very long problem. So, we're asked to find F, and we know 2 sides, and we do know an angle opposite a side. So whenever you know an angle and its opposite side, the law of sines is a possibility. However, we can't directly use the law of sines. The only thing we can use the law of sines to do is find angle E here. So let's find angle E and see where that leads us. We can say that the sine of E over 71 equals the sine of 36 over 62, and you can cross multiply, right? 71 times sine of 36 divided by 62, and you will get that the sine of E is 0.673 and a few other digits. So that's sine of E. To find E, we have to take the sine inverse, right? So E equals the sine inverse of this. And when you're doing this in the calculator, you should type every single digit in too. And then only if it asks you to round to the nearest whole number, you only do that when the problem is completely done. And when you do this, you end up finding out that E is approximately 42.307 degrees. We're not going to round it yet because we're not done yet. Okay, so now we know how large E is. We can use 42.307 to figure out how large F is. F is going to be 180 minus 36 minus 42.307 degrees. That's how many degrees are left for F, right? And in this case, doing that, we can figure out that F, which is 180 minus 42.307 minus 36 is 101.69 degrees. Again, if your calculator is giving you a decimal that goes out farther than this, goes out like maybe 10 digits, you should try to keep using them. That way you'll minimize rounding error. Now that we have F, we can figure angle F. We can figure out the measure of side F, because we know an opposite side. We know opposite sides, and we know the angle opposite F. So we can say F that we're trying to find over sine of F equals, it doesn't matter at this point, you can use either pair of opposites. You can say sine of 36 over 62 and cross multiply, and you'll find that F is approximately 103. If your number is a little off from 103, you probably were not writing all the decimal points out as you went through this problem, because it's kind of important that you keep on. If your calculator has, like the TI-80s have a second answer that lets you just substitute the prior calculation into the next one, and that's what you should do to get as accurate an answer as possible. So we got 103. We had to go through 2 law of sines to get it, and it looks like we're done, but we're actually not. If you remember, the ambiguous case of the law of sines says that when we use the law of sines to get an angle, like the 42.3 here, the calculator was really only getting us the angle in quadrant 1, the acute angle. So let's see if we could maybe there could be 2 triangles here. So if you remember, what you want to say is, what would the quadrant 2 angle be? What would the obtuse angle be for E? It would be 180 minus 42.307, which ends up giving you 137.693. And 137.693 plus 40, the angle that we know, 36, angle D, is less than 180. That means we could actually make there's an entire other triangle that we need to think about. We need to think about when E would be 137 degrees. Alright, when E is 137.693 degrees, we basically are going to go through the same steps we did in the prior problem, except instead of using 42.307, we're going to use this angle. So, our first step is going to be to find what F is for this triangle. In this case, F equals 180 minus 36 minus 137.693, or 6.307. Again, if your calculator is giving you more decimal points than I'm writing here, just keep using them. And now we're going to do this step for the triangle with an obtuse angle. We're going to say f over sine of f, which in this case is 6.307, equals sine of 36 over 62. Cross multiply, and you will find that f is approximately, ooh, whoops, I'm sorry, I just, was a mess up there. We probably saw it as I was writing it. It's f over sine of 6.307 equals 62 over sine of 36. Cross multiply and solve for f, and you'll find that f is approximately 11.5. I think on the worksheet it was 11 because the calculator I was using gave me slightly more accurate decimals. And that is one of the problems for these kind of problems that you should realize if you're doing problems that involve law of sines twice or law of sines and cosines. You can easily get rounding error, especially if you're not using all the decimal points for each step, or if you're rounding your answers before the last step. Okay, so that wraps it up for law of sines and cosines. Again, visit our website for more practice problems, 25 question worksheet, and some other goodies.